What I'm going to show you here is how to run code inside another process's event space, which is really the precursor to doing any sort of automation or writing a bot for a game. So here I've got Tibia and I've made an account, and what this is just a very simple 2D game. I use it for playing around with a lot of my experimental AI stuff. But anyway, what we're going to do is work out how we can sort of inject our own code into this game's event loop. Now, anything on Linux is probably going to be going through the X system, which means that there will be a tight event loop. Here we've got a game which is rendering at 30 frames per second. It's probably using XPending in order to check whether there are any events ready for the client to receive. For example, if I'm moving the mouse around or I click a button, such as exit. Anyway, so that function I referred to there was XPending. And if we go look that up, we can sort of see that the XPending function returns the number of events that have been received from the X server but have not been removed from the event queue. So basically what the client is going to be doing is on each loop of the rendering loop, it's going to look up, it's going to call this XPending function to check if there are events ready to be processed. We can actually use LD preload here to take advantage of that. So what we're going to do is we're going to define our own XPending function, and then we're going to tell the dynamic linker that in preference to the system XPending function being linked into the address space when the game initially loads up, we're going to have our own XPending function linked in there. Our own function can do anything we want. However, in order not to break the game, we probably want to eventually mimic the same functionality as the original function. So I'm going to make a file here called xpending.c. We're going to need a few things. The first is just going to be std.io, so we can do something interesting, like printing something out. We will need the dl function.h. Now this is the header file for the libdl. It's going to allow us to look up the original XPending function such that we can ultimately call it and return the result to the client, and that way it will appear to the client that our XPending function has identical functionality to the original. The last thing we're going to need here is x11 / x.h, I believe, which is where those x functions are defined. Now, what should the prototype for our function be? Well, it should actually be exactly the same as the real one. So let's go look up XPending again, and there we have it. And we can define it. So what we have to do here is we have to first look up the real XPending function. We can do whatever we want in the meantime. We can print things out or whatever. Usually we'd call some code within the game's address space to move around or attack a creature or something else. And then we ultimately have to return the result of the original XPending call. So what I'm going to do here is first make a static variable for the original XPending function. So we'll call that original, and it takes a display pointer, and that's going to start off live as null. We're also going to need a handle, which is a void pointer. This handle is to the x11 library, which we are about to open. Once we have that handle, we can look up the XPending symbol within that library, and then we can use it. So what are we going to do here? Well, first, this is the function that's going to be called over and over and over again. But on the first time, we're going to have to actually do all the resolving of the original XPending function, and afterwards we can just use the version that we saved. So if not original, if we haven't looked it up yet, what are we going to do? Well, first we have to open that library. So the handle is equal to, now we go over to mandl open, I believe it is. So what does this look like? Handle dl open, the file name, which is the name of the library, so libx.so, and the flags for open. You can read what these all do, but basically lazy binding is going to be a slight speed up over binding everything at once, and we only need to resolve one thing, so we may as well do it that way. So rtld underscore lazy, I'll leave everything else as a default. Now, if not handle, we should just print out the error so we know what's going on. So printf, what are we just going to say? %s and deal error, I believe it is. Okay. Now, assuming that worked, we can now resolve the XPending function. So mandl sim. So here we have original is equal to dl sim, the handle to the library that we just opened, and the symbol that we want is XPending. Okay, now if that worked, we now have a function pointer to the original version of the XPending function, so we can just return the original applied to the argument that the client gave to us. Great. Okay. So to compile that, I'm going to compile this as a shared library because it needs to be dynamically linked in the process. So position independent code. Give it out as hook.sh and dash dash shared, of course, and it's xpending.c. Great, got it. Display is not known. Else user include x11 it's xlib.h. There it goes, and great, we got it. So what I'm going to do now is use the ld preload variable, which is going to instruct the dynamic linker to look for symbols in call it hook.sh. Should have called that hook.so for a shared object. Anyway, so what I'm going to do is instruct the linker to look at my shared library that I just compiled. I'm going to instruct it to look there for symbols to resolve in preference to the system libraries. So in this case, it's going to look for XPending in hook.so instead of the system library in usr lib x11.h. Sorry, x11.so. So we'll run Tibia again, as usual. Okay, so this is a 32-bit client. Dash M32, and let's do that again. Okay, that doesn't really surprise me. The client crashed because we did something wrong. Cannot open shared object file libx.so. Is it there? No, because it's called x11. Okay, so how's that going? Look at that. So the game is running just as it was before, however it's running our code on every loop of every cycle of the event loop. So what can we do then? We can, well, first I'll prove it to you. Hello world, and compile that again and launch it. Now we can see that it's just continuously printing out hello world. Something slightly more interesting, oops, result is equal to original printf. Let's do if result does not equal 0. So if there are events pending, printf pending events %d result. So now we're going to print out the number of events ready to be returned to the client. Return result. We'll compile that again. Okay, so now it's only printing out the events when the events are actually there and ready. I can create some events very easily by just moving my mouse around. I can click on things that will also trigger events. So yeah, we're well and truly inside the inside Tibia's address space. We're able to see the number of events that are available. We could write our own versions of other functions to actually see or modify the events, but what's actually much more useful here is that once we're in the once we're in the address space of Tibia, we can actually go poke around and call the functions that the Tibia client itself implements or defines. And what's even better is that because XPending is going to be called at the top of the event loop each time, it also means